Alright, in a certain game, we get the following probability distribution. Based on money earned from the game player's standpoint, find the mean, variance, standard deviation, make a histogram. So again, we put it in our lists. We have our x values, then our p values. So we do one variable stats, but we don't just hit enter. We put in first our x value list, which is L1, comma, our p value, or our probability, L2. So we get our mean of 1.4, our standard deviation is 0.8, obviously our variance is that squared, so 0.64. For using the Inspire, it's the same thing, statistics, stat calculations, one variable statistics. This is x, this is p. These are variable references. And we get the same thing, 1.4 for the mean, 0.8 for standard deviation, square that for the variance. And here's our little histogram. The numbers are centered underneath the bars because it's discrete, and it's kind of a crappy little thing. I guess we also need a graph or a title. Game money. I don't know what we're talking about here. But that's what we do. So now, what happens to all three of those things when each random variable is increased by 1? Well, it's easier to look here because we can look at it instantaneously. So 4, 3, 2, 1. Well, what happened to the mean? It went up by 1. What happened to the standard deviation? Not a darn thing. So the shape would stay the same as well. So the mean goes up by 1. The shape is still skewed right, stays the same, and our spread stays the same because it's still the same spread out. Instead of going 3 to 0, which is a range of 3, it went from 4 to 1, which is a range of 3. Still the same. What happens to all three of those things when we multiply by 4? Alright, so let's go back and then multiply by 4. Alright, my mean got multiplied by 4. It was 1.4 times 4. And my standard deviation also got multiplied by 4. But my shape of the graph would still be the same. So the center is multiplied by 4. The spread is multiplied by 4. And if we were talking about the variance, it would be multiplied by 4 squared, because it's squared, times the old one. So it would be times 16. If we were talking about that. So what happens to SOX when we add a constant? Well, we add the constant to the mean, but nothing else changes. What happens when we multiply by a constant? We multiply by the absolute value to the mean, to the standard deviation, the constant squared to variance, and the shape is the same but more spread out. So what happens if we do both? The shape, nothing happens. The center, we multiply by the b plus the constant. So we might have to do both. The spread, you just multiply. So when you add, the spread doesn't change. We just shift. Alright, now transforming and combining random variables. This is a very important part, and it's a big part of our quiz tomorrow. So two independent random variables have the following distributions. So we found our means and our standard deviations and our variances. The mean of y was 2.9, standard deviation is 0.831, variance is 0.69. Standard deviation of x is 2.1, or sorry, the mean. The standard deviation is 0.7, variance is 0.49. So we want to put them together and get t, the combination, all the combinations of getting, or t is all the possibilities we get when we add all the x's to all the y's. So we can get 3 by 2 from the y, 1 from the x. We can get 4 by 2 from the x, 2 from the y, or 3 from the y and 1 from the x. We can get a 5 by 2 from the y, 3 from the x, 3 from the y, 2 from the x, or 4 from the y and 1 from the x. We can get a 6 by a 3 from the y and a 3 from the x, or a 4 from the y and 2 from the x. And the only way we can get a 7 is if we get a 4 from the y and a 3 from the x. So if we get a 3, for instance, it's the probability that we got a 2 from the y and a 1 from the x. So and means we multiply. So 0.4 times 0.2 is 0.8, and that's why it's over here is 0.8. Now the rest of these, they're and or. The probability of getting a 4 is the probability of rolling a 2 and a 2, or a 3 and a 1. So we multiply individually, but then we add together. So 0.20 and 0.06 is 0.26. Here we had 3 different ways. So 0.4 times 0.3, 0.3 times 0.5, 0.3 times 0.2. We get 0.12, 0.15, 0.06. Grand total of 0.33. Number 6, or getting a 6, is a 3 and a 3, so 0.3, 0.3. 4 and a 2 is 0.3 and 0.5, so we get 0.9, 0.5, 15. Add those up. And the only way to get a 7 is a 4 and a 3, so we multiply those. 0.3 times 0.3 is 0.09. And we can check that all of those add up to 1. Now, we can put those in our calculator and find the standard deviation, the mean, and the variance. But easier than that, if we add the values, we add the means. The mean of y and the mean of x, we add those two to get 5. The variance is a little bit different. The variance of t is equal to, well, I guess the square root, so the standard deviation is equal to the variance of x plus the variance of y. And that would be the standard deviation of t. So it's kind of like Pythagorean theorem. Even if we subtract, we still have this same thing. We look at the variances. The variances are the same. 0.69 plus 0.49 is 1.18. 0.831 plus 0.7 is not this. We had to do this. It's like the Pythagorean theorem. So generally speaking, if we subtract a set to find the mean, we subtract. If we subtract a set to find the standard deviation or the variance, you still add. It doesn't matter. If we're adding, like we just did, we add to find the means. You just add the two means. And again, we do the same thing that we did when we subtract. We add the variances and then take the square root. So we have to square root both of those. And that's how we get it. So here's another example. I need to zoom out a little bit here. We have a couple problems like this on our quiz tomorrow. Mr. Voss and Mr. Cull bowl every Tuesday. I'm not going to bore you with the whole problem. Voss is normally distributed with a mean of 212 and a standard deviation of 31. Cull is normally distributed with a mean of 230 and a standard deviation of 40. They're independent because they're two different people. What is the probability that Mr. Voss scores higher than Mr. Cull? Since we want to compare them, we're subtracting. We're going to do V minus C. We could have done C minus V, doesn't matter, but we did V minus C. So, to find probability, we need a mean and we need a standard deviation. And it is normal. So, to find our mean, we find the mean of Voss, subtract the mean of Cull, because we're doing V minus C. So 212 minus 230, our new mean is negative 18. Our standard deviation is a little bit tougher. Our variance is equal to the sum of the two variances. So the variance of Voss is 31 squared, and the variance of Cull is 40 squared, because the standard deviations are 31 and 40. So really, again, it's like Pythagorean theorem. A squared plus B squared equals C squared, where A is a standard deviation of, let's say, Voss. B is a standard deviation of Cull. And our new one, C, is a standard deviation of our new set, the difference. So that's how we find our standard deviation, and it turns out to be 50.6. So then the work I want to see is this. I want my normal curve with the mean marked -18, standard deviations 50.6. Now I want to know the probability that Mr. Voss scores higher. So if we're looking at this equation, if Voss scores higher, then D is positive. And if D is positive, that means it's greater than 0. So we want to find the probability that D is greater than or equal to 0, because it doesn't matter if it's equal, because it's continuous data. So we marked 0 on our graph. We want greater than, so we shade, because we want to see, again, if Voss is better than Cull. And obviously it's less than 50% because it's on this side of the mean. So we use our norm CDF. Again, I don't want to see that. This is the work I want to see. All of this stuff. So we do, if you're using the Inspire, probability, distributions, normal CDF, lower bound 0, upper bound our version of infinity. The mean was -18, and our standard deviation was 50.6. So we got a probability of 36.10. Don't tell me 36. If you're using the 84, go back to our distributions, normal, CDF. We start at 0, we go to our version of infinity, our mean, don't want to, alright, I guess I have to do that all again, normal CDF, 0 to positive infinity, our version of, comma, -18, comma, 50.6 for our standard deviation, same thing. So we get a probability of 36.10% or 0.3610. So really I want 4 numbers here. This is the work I want to see. I want to see the normal curve. I want to see this. And this is how you find the mean and standard deviation, and that's what you need to find probability. And that's how you do what we're doing here.